In question number 1.4 and 1.5, we will be demonstrating an ICMP packet spoofing attack. ICMP stands for Internet Control Message Protocol. It was used by network devices to send error messages and some operational information. Most use case, like most common use of ICMP is the ping command, which sends ICMP echo request packets and expects ICMP echo reply packets in response. In this attack, host A will be sending ping requests to IP1, which is 7.7.2.4, like it's derived from the last four digits of my student account number, which is S420774. This IP does not actually exist on the network. Uh, Normally, host A wouldn't get response. However, an attacker is running a Python script using Scapy that will sniff the network for ICMP echo request from host A to 7.7.2.4 every time it will detect one. Host A received this false replies and believes that as 7.7.2.4 is actual real reachable host, our network will have some three machines, the attacker, the host A, and the host B. And it is compulsory that all the machines are on the same subnet through bridge interface. Let me show you the Docker containers, but before showing you the Docker containers, I need to navigate to the lab setup file that we have. So downloads, ls, cd lab setup, okay, um, ls, cd setup, okay. Now that we are here, let us see if the all Docker containers are up using the docker ps command. Yeah, as you can see, uh, we can see all the three network containers running at attacker, host A and host B. Uh, Now let me show you the ICMP spoof script that I have written. I guess it is in like the home, yeah, the home directory, ICMP spoof.py. So cat slash home slash Harshal, oh sorry, Harshal ICMP spoof.py. Here, here, uh, this line shows like we import everything from Scapy, that allows us to sniff and analyze network packets at very low level. Here we define a function. This function automatically is automatically called every time the sniffer captures a packet, which matches with our filter. The filter here, the um, yeah, this exact command here, the line 3 exactly checks two things. First, it checks if the packet contains an ICMP, like ICMP layer. Second, it checks if the ICMP is type 8. In the ICMP protocol, that type 8 is meant by the echo request. This is the packet we sent when you run the ping command. We only want to respond to ping requests, not to other ICMP packets. Uh, as you can see, the IP source packet here, this creates a forged IP header. Now notice how we flip now notice how we flip the source and the destination to the source of our reply is set to 7.7.2.4, which was the destination of the original request, and this makes our reply like appear that is coming from 7.7.2.4. uh, this here, the destination is equal to packet IP source. This is our destination and it's set to 10.9.0.5, which was the source of the original request. This sends a reply back to host A. This is the core of spoofing attack. We are all pretending to be 7.7.2.4 by setting the source IP to 7.7.2.4, even though we are actually the attacker machine. Uh, Here, ICMP is equal to type 0 echo reply. In this section here, it creates a forced IP ICMP header with three important values. First of all is type 0. Type 0 means the echo reply. We are changing the type from type 8 to type 0 to make it look like a legitimate response. Uh, Here the sequential packet ICMP sequence, we copy the exact same sequence number from the original request. Host A uses this to match the exact specific ping reply to the corresponding request. If this sequence number does not match to host A, uh, will the host A will ignore our reply by both copying ID and the sequence number. Our false reply looks like it is coming, like it is coming from an exactly authentic source. The data packet that is written here, this line copies the payload data from the original ping request into our forced reply. A real ICMP echo reply always echoes back to the same data that was in request. By copying this data, we make our forced reply look even more indistinguishable from a real reply. Uh, Here, the spoof packet IP ICMP data. This completely assembles the forged packet by stacking IP, ICMP layer, and data together using the operator uh, in Scapy. Then this send transmit the forged packet into the network where verbose is 0. Suppresses Scapy's output so only our custom print statement appears. This is the just the normal print statement. Okay, so now let's run our spoofing. Before we run our spoofing, I forgot to mention one thing. Um as you can see, this is the main sniffer packet, the BR2686 BBC. Listens on the bridge interface that connects all networks. The filter is set onto ICMP and the host is on 10.9.0.5 and the destination is set on 7.7.2.4. This we can also call it as at a something like Berkeley packet filter that tells Scapy to only captures the ICMP packets where the host is 10.9.5 and the destination is 7.2.4, which is the last four digits of my student ID, which is S4207724. This makes sure that we only respond to host A's pings and ignore all the other traffic. So let's just quickly run our script. Sudo python 3 slash home slash Herschel slash ICMP spoof.py. Yeah, so it is waiting. Now let's start our sudo wireshark first. Yeah. Oh, it might need to install sudo wireshark here. Done. Let's just start our wireshark. Yeah, as you can see, I'll select interface B and apply a filter of ICMP as we have seen. ICMP, yeah. Okay. Now I'll enter like open a new terminal to log on and enter host A and ping it to like 7.7.2.4. So let's execute our host A. Oh, sorry, host A 10.9, sorry, 10.9.0.5 slash bin slash bash, and let's ping it to 7.7 sorry 7.7.2.4. Okay, now 7.74 does not exist on a network. Normally host would get response and the ping would time out. But watch what happens. Host A is receiving replies from 7.7.2.4, but remember 7.7.2.4 doesn't exist. These replies are being forged by the attacker. Uh, Now I'll show you the attacker terminal where we have, yeah, captured ICMP. As you can see, these are the request. The sniffer detects host's ping and is sending forged reply The attacker immediately is sending a forged reply. This is happening in real time for every single ping packet. The attacker intercepts each request and sends forged reply like before this host is timing out. Now let me show you the Wireshark. Oh, this is, yeah, sorry. Yeah, let me show you Wireshark to confirm this packets individually. See, the odd packets are from like 10.10.9.0.5. Uh, these packets are having an echo, as you can see here. Yeah, if I click on one of those packets, I can see the source. Uh, See, I can see the source and the destination IP. ICMP type reply is echo. Like as I've clicked this, yeah, the code is type 8. Okay, type 8, type 8, echo ping request. Now, sorry, just yeah. Now, echo time code is 0. This is exactly what a legitimate ping request looks like. In order to summarize the ICMP attack that we just did, the BPF filter ICMP and source host 10.9.0.5 and destination is 7.72.4 precisely only targets host Ace ping to 7.7.2.4. Uh, just yeah, is it? Yeah. The forged IP header uses a source packet IP to destination to impersonate, like to make sure it is a fake. The forged IP header uses type 0 for echo request replies. This might lead to, see, uh, a fake request. Host A has no authentication mechanism to verify the true source of ICMP reply. It simply checks the ID and the sequence number, which we copied perfectly. This attack demonstrates a fundamental weakness in ICMP protocol. There is no way to verify a reply actually came from the claimed IP source. This same weakness is exploited in many real world attacks, including the reflection attacks and some of the amplification attacks. So, thank you so much.